talk about the why the reaction is important and how to design reactors really for the environmental engineering. So we have talked about the kinetics, and we have talked about the kinetic blades actually, right? And there are different kinetic blades called absolute blade and volumetric blade and specific blades. Well, specific blades is totally related to your diet program, right? You guys know why. And then we have talked about the sequential sequences of the reactions, parallel reactions and serial reactions, and also we have talked about the concentration profile, which shows the serial degradation. And also we have talked about the complex reaction, and then we have talked about the irreversible and reversible reaction. And we have talked a little bit about the thermodynamics, delta G, and then the relation between reaction quotient. In case of delta G is greater than 0, that means irreversible reaction occurred. I think you guys already know that. And then we have talked about the catalytic. Did we have talked about catalytic reaction? Even not. Okay, so that means it is time to start the show. All right. Catalytic and non-catalytic reaction. I just forget his name. What's your name again? Ted. Okay. Mobile command. Yeah.
Actually, I was watching video at the time.
You're watching music videos?
Mirror.
Mirror?
Yeah.
Why? Do you have any reason to show me better? You know, I'm not that kind of. You are not my type. Right? So, good. What is the role? Then my question starts. What is the role of catalyst? We already said that before, right?
Make lower activation.
Okay, right. Catalyst actually lower the activation energy of the reaction. One good thing for catalyst is catalyst just participate as a accelerator. That's it. Because your father and mother always talk to you. If you did something wrong, there should be, effect and cause and effect, right? Right. So that means something happened, some effects, some actually, spend there. But catalyst, it just actually it participates direction, but it just tosses electron, right? That's it. And then catalyst itself doesn't change. This is very wonderful thing. Although you are using diamond or platinum or bunch of very precious metal catalyst, this is the reason why you can use catalyst. If you use gold catalyst, but it just consumed in 5 minutes, whoever want to use the catalyst, the catalyst itself actually take the electron and then toss it to the reaction, and that can accelerate the reaction. This is the wonderful part of the catalyst. And there is some, different types of catalyst. We call it, the person called it homogeneous catalyst. And the other one is heterogeneous catalyst. So, what's the difference between these two? What is the meaning of homo? I really don't have any intent, maybe. Homo. What is the meaning of homo? Latin prefix. We are homo. What do you mean? We are the same, right? The same. Hetero. Different, right? So homogeneous means the same phase, and the heterogeneous is the different phase. So this means different phase catalyst, and this is same phase catalyst. If the reaction occurs in aqueous phase, in water phase, if the catalyst is water or aqueous phase, that is homogeneous catalyst. If it is solid, that is heterogeneous catalyst. All right? So what is the example of the homogeneous catalyst? We always know there are many heterogeneous catalysts, right? As I already taught, gold and precious metal, platinum or palladium. Well, somebody say, well, palladium and platinum could be used as a catalyst. Platinum is much more, expensive than gold, right? So in that case, you guys can say, why don't you just use palladium instead of the platinum? If so, palladium is cheap. Well, actually, what do you think about that sketcher? My question, you guys are really, really out of mind. My question was, is palladium cheap? Have you heard about palladium? No?
I am not.
Yeah, palladium is not cheap. Palladium is very expensive. So, but the important thing is palladium is solid in atmosphere. I mean, in this temperature. So, palladium in water. Well, let's say already talk. This chemical compound is very toxic and very stable, actually. It's already called. We call it mono, di-bi, or tri, or tetra. Tetra means four. So tetra chloro, this structure is ethene or acetylene. So we call it tetra chloroacetylene. This is very good, solvent for the dry cleaning. Actually, it was used 1970s in Korea in every, every spot in the world. But the problem is this compound have chlorine, which is a fire. It can cause very significant, effect on human health problem. So. Most of the scientists actually want to degrade this one. This is very easy to degrade because you just cut down this chlorine and you can finally have acetylene, right? How can you degrade this chlorinated compound to acetylene? Chemistry major.
Catalyst.
Huh?
Use catalyst.
Well, that is kind of a little bit extremely. Chlorine is actually belong to which group?
Halogen.
Yeah, and halogen. And 7. I think what? 7A? C? D? 7A? Halogen is 7B, right? And near the inner gas. That means this is highly oxygenated. I mean, the oxygen redox potential. If the number is percent high, that means it is oxidized, and low, that means reduced. So chlorinated or halogenated means highly oxidized. So what do you want to do to degrade this halogenated compound? Chemistry major? Do you want to add more oxygen, or reductant or oxidant? Which way you want to go to reduce or to degrade this one? Well, you can actually degrade this one by oxidizing. Let's say if you just put it in 10,000 Celsius degree, this chemical compound degraded. Okay. Yeah. That means oxygen. So 110,000 Celsius, that means oxidation actually. But is there any way to reduce this one?
Why not reducing the water?
This is very, non-polar, so it cannot be easily dissolved. So one of the easiest way is just to put it electron here, around the 8 per electron. Because 2 electrons is needed for this one, you need to actually add 8 electrons. You easily detach this chemical structure, actually. Well, you can degrade it in 10,000 Celsius degree furnace. And also, you just put it just 8 electrons to degrade this one. So which one is much more easier? Put it in the 10,000 Celsius furnace, or put it, well, just think about this. We just put it, just a cell, electricity cell, battery, and you can get easily degrade this one, right? So, in this case, as Delphine said, well, this chemical actually contaminates most of the groundwater in the United States. 70% of United States groundwater actually contaminated by this toxic chemical. So think about that. In this water, this chemical actually stay here. If you just want to put some reductant actually can donate the electron, right? So it can easily detach this chlorine. The problem is, this is not easily solved. It cannot be, degraded in the same phase. That means if you want to degrade this one, you need to have surface. Wow, this I'm I'm going too far, right? 기철아, 이해하겠니? 내가 지금 무슨 말하는지 하나도 모르겠지?
이게 우리 현실이나
Okay, let's start it here. Right, so homogeneous catalyst, I just want to give you, ester hydrolysis. Have you heard about the hydrolysis? Delphine, have you heard about the hydration? What is the difference between hydration and hydrolysis? You run the 10,000 kilometer, and your body is fully fully dehydrated, right? So that means,
That's important.
yes. Can you say this is hydrated, dehydrated, hydrolysis, hydrolyzed, dehydrolyzed? Can you put it dehydrolyzed instead of the hydrolysis? The sentence I have used before. What happened if your body is totally dehydrolyzed or hydrolyzed? Result. So when you are thirsty, that means you are dehydrated, right? That means H2O actually, right? So H2O is just evaporated from your body, right? And you need kind of thirst quencher, well, including H2O, right? But so you can say hydration or dehydration is kind of related to water, right? So if so, what is the hydrolysis chemistry major?
Degraded by
You can speak up. Degraded by what?
water.
Water? I cannot hear you. All right. Well, actually, if you just degrade water, you can have hydrogen ion, proton, and hydroxide, right? So hydrolysis means these chemicals are involved in the reaction. So that means if your body is in hydration, that means water molecule is fully inside of your body, right? This is very good. But the important thing is, if your body is in hydrolysis, means this chemical, well, as you know, let's say the pH is 1 or pH is minus 14. So this actually active ions fully attack your body. So your internal, system actually affected by this chemical. So you really need to be very careful when you're using hydrolysis and hydration. Hydration is related to water molecule, and hydrolysis related to the chemical compound, reactive chemical compound, proton and OH minus. This is very, very important. All right. So, ester hydrolysis. What is the ester? Just to check it, I spent much time on it. And as I will talk, the example of heterogeneous catalyst is here. If you just put some, this water is contaminated by this chemical, you want to add 8 electrons here. What kind of reactant do you want to add here? Well, if you just add zinc 0 or Fe 0, we call it zero valent metals. Just put it inside here, it can produce electron, and you can fully degrade this chemical with chlorine, and you can have like this. So in the United States, even in Korea nowadays, well, think about this. This is kind of chemical company, and there is very big underground storage tank, and this tank is filled with this toxic chemical. The problem is it can be easily destroyed. So the PCE, the tetrachloroethylene, can be easily leaked out And here, if the this is well, most of the civil engineering students know this is water level actually, right? So this is under the ground, well, like this, and the groundwater actually fully saturated in this area. So the groundwater itself marching a certain direction, like this. So the chemical leaked out from this underground storage tank contaminates. Well, in Korea, actually, the contamination is not that significant because there are very big block and the soil material is just like the clay, so it cannot be easily, the contaminants easily can be transported. But in the United States, in a year, well, maybe 1,000 meter actually can be contaminated. So this is the reason why the United States just put tons of money to clean this contaminated area. One interesting remediation technology is just drill this and then make big hole and then just put the zinc or Fe0 suspension into the ground, and this can be easily mixed up here, and this chemical can have this kind of reaction, and then you can have this non-toxic chemical. This is one of the remediation technology which attracts the attention 1990s and 2000 actually. Simple, isn't it? So in this case, well, this one is a sort of reactant, but we want to accelerate this reaction, right? So in my research group, we actually developed some kind of electron transfer mediator. We just put some polymer here. So the polymer placed it in this direction, and then this is just like this. Well, let's say this is Fe0 surface, and the chemical dissolved on the surface. So here, the electron like this. So two electrons can be transported to this chemical, right? So you can actually detach one chlorine here. But interesting thing is, if you put some natural polymer here, let's say this is under natural polymer actually dissolved here, and then the contaminants actually detach it from this surface. So at first time, the electron goes this polymer, and then polymer actually toss the electron to this one. Well, it is a little bit weird, right? If there is one people or another, thing intervene the reaction, usually the reaction, delayed, right? Let's think about this. I love this one, and then there is one messenger just to send my intent to him. Well, the relationship cannot be easily developed, right? Well, I'd better talk to him. I love you. That means we can develop the relation much more, faster and easier, right? So in the human, society, the messenger is kind of, delaying effect. But in this direction, as you can see, you can say the electron transfer is much more faster because there is this is kind of, messenger, right? But in the reaction, world, this material can accelerate the tossing electron, procedure. So this is very, very important one. But one good thing is this can be produced by the microorganism in natural environment. You found that actually. All right, so we can say this is heterogeneous catalyst. And homogeneous catalyst, ester hydrolysis. Well, acid can be homogeneous catalyst because acid itself is aqueous phase. So you just put some ester compound here and put some acid here. The reaction can be accelerated. And finally, you can have a bunch of different, and then there is non-catalytic reaction. As I recall, non-catalytic means no catalyst reaction, which is much more, slower reaction compared to the catalytic reaction. There are so many interesting things around here for the diffusion things, but I just want to skip this. And then, photolysis reaction. Mostly, this catalytic reaction can be used as redox reaction. Redox means reduction and oxidation reaction. It is combined word. What is photolytic reaction? Yeah. 뭐 같냐? photolytic reaction. 그치? You can be saved, actually. Focus on it. Did your girlfriend just, went away? Why you just, 내 생각하고 있었단 말이지. 이러면서 밖에 보면서 그지? My God. Even Adeka understands what I'm talking in Korean. Man, don't bribe me. So, photo means light. Right? So, there are so many, reactions. Well, I think I already talked about the photo reaction, UV, visible, X-ray reaction before, right? And then there is radiolytic reaction, which involve the uranium and the plutonium. One interesting thing is there is very big, as I already thought, uranium ore near the Yeoncheon area. Yeoncheon is a little bit 40 kilometers away from Daejeon. So the uranium, dissolved uranium can be transported to the groundwater of the Daejeon. We actually measure the concentration of uranium-6. We can detect the concentration actually. So you are actually drinking uranium encrypted water. But I really don't know actually that concentration can cause your health, that or, as I already taught, in ancient days, the small amount of toxicants actually can, make you healthier. So we don't know actually. All right. Now we need to talk about the mechanics. now we are talking about mechanics and directions. By the way, what factors can affect this direction? Something. What factor can affect, influence the direction? Huh? Temperature. Yeah. Right. And anything else? Sam over there? My question was, what factor can affect direction, chemical or biological? Only said that?
Maybe different indicators.
Different indicator?
Yeah.
What do you mean by different indicator?
The compound that can help for reaction. Catalysts.
Yeah, well, catalyst. Great. And you want to get high and you start to drink. So if you want to get more high and higher, what do you want to do?
Less degree. For example, if you drink first water and then beer, you're going to become much.
So that yeah, that's right. But can you could you just summarize a little bit more scientific way?
Then drink more.
Yeah, and can you do it more scientifically? Increase of alcohol, right? So concentration is very, very important. All right. So let's talk about the concentration of the reaction. Okay. Depending on the concentration of each different chemical compound, we can put the different orders. So I think I already talked about this one. We usually talk about nth reaction order because kinetic rate actually this could be dCA over dt. Right? Let's say Ca is concentration of some chemical compound, right? And then in this case, if you just put it as K0, we call it, this one is zero order reaction. And then if this one is K1, Ca, we call it first order reaction. And put it scared. We can say, right? But here, A plus B goes C, like this. If the reaction, in this case, we can put it as, although this is dCA dt, well, we can put it as K, Ca, Cb. But these all have, each one, you call it, this is second order reaction, right? Finally, if R is Kn and C, A, N, this is nth order reaction. Okay. Or it can be a little bit much more interesting and you guys can say. Now, let's move to the another temperature. Well, you guys know that this is just a kinetic part, but in thermodynamics and the equilibrium side, you already know one good chemical law by French chemist. If you increase the concentration of A, what happens? Direction goes, yeah, this way. What about if this one? So we call it reversible reaction. I don't know, I think. Oh, man. Okay. Whatever. So, who is the guy? Okay, this is time to hear about the French name by French girl. Something like that. Chatelier. Le Chatelier. Slow. Maybe my pronunciation is not that good, you know, in French. I really don't. I don't know, but just I can write it in Korean. Le Chatelier is slow. I really don't know. Chatelier.
Le Châtelier. Le Châtelier.
Chatelier.
Le Châtelier.
Okay. Well, you guys know this log is, you know, to decide if you increase the concentration or decrease concentration, you can, you know, estimate the direction, which is very, very important. All right. Temperature. We already have talked about the effect of temperature. Who is the guy, you know, give very significant impact on the temperature in type of direction? 희건아, 누굴까? Yeah, well, Le Chatelier is the, you know, the chemist, French chemist, who identified the concentration effect. And who is the famous chemist who you know, identified the temperature effect of the erection? We talk about this Arrhenius, right? Arrhenius equation. So you guys already know K equals A exponential and minus EA and RT. You guys can have the direction. Well, here you can have rate constant, rate constant, and also you can have temperature reciprocal, and you can have this kind of nice relation. And here you can have let's see, EA, and here you can have some. You just put the log here, let me see, natural log. Right, and then you can have A as an intercept. Okay, there are another types of many different temperature rated, you know, equation. Here. Okay, and then think about the important thing in chemical reaction to design the chemical reactor. Well, as Sam said, catalyst is very, very important. To increase the or decrease catalyst, you know, amount is very, very important. Think about that. You can see the when you just come to school. If you just look at the muffler of the car, you can see the muffler is always crying, right? You can see the water just comes out from the muffler. right? That is not the gasoline, that is water. So most of the cars produced in 2000, the cars usually have very good, heterogeneous catalyst. As I already talked, palladium in there and rhodium in there, so it can, chemically convert it to a whole bunch of NOx and SOx, and it can produce water, right? So think about that. Grandeur, which is being produced by Hyundai automobile company. The rhodium and the palladium price is very high. So what they want to do is how much amount is proper to convert those chemical to the water. That is very, very important thing to them. If they can save 10% of rhodium and palladium amount, well, they can actually decrease the price of grandeur. This is very, very important thing, right? So some of the material science professor in KAIST actually has some, big project from Hyundai company, and they actually develop very nice catalyst, and they can reduce big amount of the catalyst actually. So, it was in the middle of 2005. So at that time, the car price actually dropped. That is not the kind of economical tactic. That is actually due to from the successful investigation and development of catalyst. Wow, right? So catalyst amount is very, very important. And our future actually rely on catalyst. I'm not just to give the material science student rules the word. I'm just talking to you. The energy is the problem actually. Energy and environmental always go together. That is very, very important. But nowadays, energy, they are talking something. Most of the people here believe the charcoals and the gasoline, not charcoal, gasoline can be disappeared in 100 years actually. That is true. That is true. But the problem is how can we smartly use the charcoal? I think we can use it for 300 to 400 years. So maybe during the 300 years, our family, my kids and kids can use it very in good mood. But maybe after 300 years, they start to think about that. How it got. To use the charcoal smart. Charcoal is kind of stone which include carbon, and include sulfur, include a whole bunch of chemicals in there. So China actually didn't care about that. 1960s and 2000, China just used it. So the developed country just talk to them, stop it. You are contaminating the world. China, you are doing the wrong, actually. Well, actually, they did the wrong. Well, they didn't actually hear, other, countries, But nowadays, China, started to understand their environment actually destroyed by the burning of charcoal. They are really, really doing big research on the how burning charcoal is smart. That is very, very important thing nowadays in China. And then, as a write-off, if you just develop some nice oxidized catalyst for burning charcoal smart, well, you can actually earn, a bunch of money. This is very, very important. Well, you guys can say scientists and even engineers cannot have, enough money. But that's right. That is maybe 1970 or 80s actually, business work. But nowadays, scientists and engineers are so smart, and they know the flow of money. You guys know that, right? I already said that about, that, so you should know this. This is very, very important. Never ever give free ride to your friends or to your partners. Just ask them money. Whenever you give consultation, this is very, very important. This is the starting of your business, actually. Well, somebody just came to you and asked, some kind of how can I, have nice girl, or how, meet nice girl, I mean. And well, you can give it, freely, but now is time you just start your club and charge time. Maybe you can have, $10 per, hour or something like that. This is very, very important. This from the catalyst side story, actually. All right. So I just talk about the amount of the catalyst, right? So if you know the amount very well, you really need to know about the stoichiometry. What is a stoichiometry? I'm not going to ask you chemical major. All right, the guy over there. What is a stoichiometry? Yeah, you. What is it? Stoichiometry? You know? Okay, we'll say chemical balance. Oh, well, for example, you guys know charge balance. Right? So, well, how fast the reaction goes, this is related to chemical reactions, right? So how much amount of reactant can react or produce the products? This is related to stoichiometry, actually. So let's say nu A plus nu B plus there are lots of more reactants. After reaction, you can have nu PP plus nu A nu Q plus lots of different. Well, this is, we could say, reactants, right? This is products. So, using the equilibrium theory and kinetics, you guys can estimate the amount of these chemicals needed for reaction and the amount of chemicals can be produced after reaction. This is very, very important. Right? Okay, I think I would like to start here. And well, as I already talked, this is kind of environmental engineering side, but this is totally different to environmental science. Maybe 40% or 45% can be included in final exam. So you need to focus on my lecture, and then you need to read on your writing. There is no slides, and there is no updates on site. So and then I will give you a couple of homework, which can twist your brain. I think I'm very challenging. Why? What's supposed to be the problem? Well, I just sent email to tell you. I really don't know why you just talk to me if you cannot easily solve the problem. Well, I can, give you, and my assistant can give you kind of, exercising session for, solving the, homework, and even exercising section for the midterm or final term exam. We can do that. But nobody can, ask me before. So that means you guys are so brilliant, and most of you fully understand what I'm talking during the class, right? So I really didn't have any doubts. You guys have such kind of problems. But Ted just sent email. I think he is kind of clever guy, and most of the people here have some difficulties to solve the problems. Chapter 4, right? No problem with you, Adhika? Well, so let me know. I will just talk to my assistant. We have two actually assistants. They are very, very brilliant guys. So you can have exercising session. You guys can ask any kinds of questions for solving the problem, right? And one good part is if you ask them in French, they answer for you in French. In Korean, they can do for you in Korean. Russian, I really don't know. Anyway, so that is, I think, a wonderful part. So use the session well. All right? Any questions? Okay, thank you very much.